Good morning, everyone. Happy Friday. We are going to continue with our symmetry and rotations of symmetry today. So you need to get your packet out. And please remember at any time if you need to pause or rewind the video, please do so. We're going to be looking at last night's homework or yesterday's work or last night's homework depending if you got it done or not. We needed to figure out which letters had vertical or horizontal symmetry. Here is your answer key. If you look, we did 8 together. Remember, if you cut it in half, you have a vertical symmetry. It's the same on both sides. The M is the same way. The T, the U, the V, Y, and W. If we look at horizontal symmetry, it's when you cut it in half. The B, if you cut it right across the middle horizontally, it will be equal on either side. The C, the D, E, and the K are also letters with horizontal symmetry. The ones in the middle are the ones with both. That means you can cut it in half both ways, and you have 2 lines of symmetry through each one. So please check your answers. And then these are the letters that do not have any horizontal or vertical symmetry. For the second part of your worksheet, you had to draw one of the shapes, and then you had to reflect it over the x-axis, which we colored in yesterday. So if we plotted our 0, 4, 2, 1, and 4, 3, this is your original shape. And then we needed to flip it. We needed to rotate it over or reflect it over the graph. Remember, you count. How far away is B from the x-axis? It's 1. So this B needs to be 1 point away as well. C is 1, 2, 3. So it needs to be 1, 2, 3 in the other direction. A is 4. So it needs to be 4 in the other direction. And it does ask for your coordinates. So please make sure that you have written your new A point, B point, and C point right here. I'm going to come back to your rotational symmetry in a few minutes. I want you guys to flip to the last page of your packet, practice 9-10, because we need to talk about rotations before we do anything else. A rotation is when you have something and you rotate it. Rotate, rotate, rotate. What you're going to be doing is rotating a shape 90 degrees, which is a quarter of a rotation, 180 degrees, which is halfway around, or 270 degrees, which is 3 turns around, and 360 puts you right back to where you started from. If you need to draw this to remember your degrees, I highly recommend it. So I want to start with shape 3. I want to start with a diamond. If we were to turn a diamond to the left 90 degrees, so which is a quarter of the way turned, just turn your diamond to here. Is this shape exactly the same? And as you can see, it's still a diamond. If you turned it again 180 degrees, your shape is still the same. So what we need to put for our answer for number 3 is we need to put that there is rotational symmetry, and it's always going to be the first rotation you make that shows the same shape. So in this case, when we turned it 90 degrees, you still had a diamond, so it's going to be yes at 90 degrees. Now I want you to look at number 2. The rhombus, if we were to turn this 90 degrees, your rhombus would be vertical, and it would not look like this. However, if we turned it again halfway around to 180 degrees, it would look the same. So your answer is here, yes, at 180 degrees. If we took the letter T, we turned it on its side, does it look the same? No. If we turned it 180 degrees, does it look the same? No, it's upside down. If we turned it 270, does it look the same? No. So your answer for the T is no, because it doesn't have a rotation symmetry. For number 4, I drew the shape for you, so if you need to pause the video at this time, please do so. The points are 1, 4, 1, 1, and 4, 2. What we're going to be doing is rotating this triangle over the y-axis at 90 degrees and then over the x-axis for 180 degrees. So we're going to be rotating it just like we rotated these shapes. So I drew you a little triangle that we're going to be rotating. So I'm going to label this B, A, and C. If we were to rotate this 90 degrees, we're rotating it a quarter of the way. So your shape is going to look like this. When we plot our points, you're going to plot the B the same amount of spaces away from your y-axis. So in this case, it's 1 space away. You're going to plot it the same way. Now for our C is going to be at the point -2, +4. Okay, your C is up here. The C is 4 spaces over, so now it's going to be 4 spaces up. Your A is 3 spaces away from the B, so your A has to be here. And now you have your new shape. Make sure you label your points -4, 1, -1, 1, and -2, 4. Then we need to rotate it one more time to get it to be 180 degrees. So your shape is going to look like this. The B will be here, the C and the A are going to be here. The B, your B point is still going to be 1 space away from the x-axis. Label your B. I'm going to label it B2. Your A is still 1, 2, 3 spaces away from the B. And your C is still going to be at -4, -2, still going to be 4 spaces away from your axis. So please make sure that you write down these points: -1, -4, -1, -1, -4, -2. I want you to try number 5 on your own, and we'll review this when I get back next week. So I want you to look at this example and the shape, and I want you to rotate it 90 and 180 degrees, and then write down your points. When you're finished with that, I want you to go back to the rotational symmetry page that you had yesterday. You should have, at this point, your lines of symmetry drawn. If you need to check your lines of symmetry, I will draw them for you here. In this first one, you have a line of symmetry going down the middle. When you have a line of symmetry here, if you were to rotate this, the question is, can you rotate it 90 degrees, 180 degrees, or 270 degrees to be this same shape? And that's what you're going to figure out today. For the next one, these are your lines of symmetry, so please check your answers. We've done a star before. It goes through every single point. This one you have one line of symmetry. We've done equilateral triangles before. Here are 2 lines of symmetry in that one. There are no lines of symmetry in this shape. For the moon, you have 1. for this pentagon, you have it through every point. And then you have this octagon, goes through every side and every vertices. So now that you've checked your lines of symmetry, see if you can figure out what the rotational symmetry is. How many rotations can you make for that shape to look the same? So you can work with a partner on this, and we will go over this when I come back on Monday. Have a great weekend.